All right, hello kids. We're going to start lesson 13 now. More standard deviation. So this is our goal here. We're going to try to get more advanced ideas on how to do standard deviation, what it means for us. So they start out this with a little bit of mental math. So they start out here, it says evaluate mentally. You got 0.5 times 30. So remember 0.5 is essentially a 1/2. So you're talking 1/2 of 30. So hopefully you can do that mental math in your head. Take 30 and split in 2 equal parts. So that's 15. 1.5 times 50, well, that's just a little bit of mental math there. And so hopefully you can come up with 15 in your heads. And then 100 minus, you already figured out what this was, right? That's the same thing here. 1.5 times 30, that's 45. So 100 minus 45 is going to be your 55. And then down here, you got 1.5 times 18. So you do the math on that first. And you'll have 100 minus 27. It gives you 73. Of course, remember when you're doing this, always keep in mind of PEMDAS. Let's write those down just as a review. Powers, no, excuse me, parentheses, exponents, multiplication and division, addition and subtraction. So you're going to want to take care of the parentheses and the grouping symbols first. Then move on to exponentials, exponents, and then multiplication, division, addition, subtraction. All right, so make sure that you are evaluating that first. So then, for example, we would do the multiplication here and here before we do the subtraction here and here. Right? Now they have this little 13.2, the info gap, and they're basically talking. You either have a problem card or a data card to show the difference between African and Asian elephants. Unfortunately, I don't have that. I'm not sure if the school got one or if it just got lost in a matter of time, but nonetheless, I do not have what they asked for in 13.2, so we'll bypass it for now. Maybe catch it later and see what we can do. But moving on, going to start in on 13.3, interpreting measures of center and variability. I've always been taught to say measures of center, central variance, but measures of central tendency, that's the big one for me, central tendency. You'll hear that a lot. Okay, so we're going to find the center. Of course, your 3 methods of central tendency are going to be your mean, the median, and the mode. And they all have their advantages and disadvantages, so you kind of work with that. All right. And let me just move my little face out of the way here. All right, so let's just go through these and see what we got going on here. It says for each situation, you're given 2 graphs of data, a measure of center for each, and a measure of variability for each. They interpret the measure of the center in terms of the situation, interpret the measure of variability, compare the 2 data sets. Right? And so they start out here. The heights of the 40 trees in each of the 2 forests is collected. All right, so they're telling you that the mean is 44.8. So right about, I'd say probably about 44.8. So right about in here, that's about where your mean's at. And your standard deviation is 4.75, so it's pretty well clustered right around there, as you can see. I don't have too many outliers, just like one up here at 55, which is kind of odd. One of the little small ones down here by 35. So that's all that's really going on there. And then we compare that with the one that's right below there, a mean of 35.03 feet. So you can see you went from 44 up to 56. So that's a pretty good jump. And the standard deviation went from 4.72 up to 7.87. So this one is small, or has a mean that's down here. The mean for this one is like over here by 55, so it moved the whole business up. But you can see how much more spread out it is. I mean, it ranges from 40 over here to 70, so that's a big range it has here, as opposed to here you only have from 35 to 55, a spread of about 20, as opposed to a spread of like 30. Okay, and so interpret this. Well, let's see what we got written down here. It says tree height in forest A is shorter than B. Yes, because the mean is 44 versus 56. The tree height in A is shorter than B. And there you're comparing the two numbers. But forest B trees have greater variation in their heights. Yeah, well, if you look at this, your standard deviation, 4.72 versus 7.87. Yeah, there's more variation in the heights there, even though it has a higher height. Okay. And let's look at number 2 here. It says, let me go and get this right. It says the number of minutes it takes for Lynn and Noah to finish their tests in German class is collected for the year. All right, so if you look at this, what do we see? Well, we got a 29.48 versus a 28.44, so that's pretty, those two numbers are pretty close. I mean, you're only off by a minute. I mean, you're a little bit longer here, but maybe like a minute, so not too much difference. Let's look at the variation, though. You have 5 minutes here, and you have 7.4 minutes. So this one went up quite a bit. So what's going on here? So the mean that you have attributed to A is about equal to the mean that you have on B. And then if you look at the standard deviation of A versus the standard deviation, let me go and make that a little bit prettier. Standard deviation for B, well, this is quite a bit bigger, right? Standard deviation for B is quite a bit bigger than A. So that's what's going on here. So you see all the variations. Sometimes she got done in 15 minutes, and sometimes it took her 42 minutes to get done. Or excuse me, it's Noah. It took Noah a lot bigger spread to get done, as opposed to Lynn, which took anywhere from 20 to 40 minutes. So, yeah, they both had about the same mean, just that looks like Lynn was a little bit more consistent on finishing this thing at a steady pace. Okay. And moving on to number 3. Let's look at this. Some histograms. Let's look at some histograms. And number 3, it says the number of raisins in a cereal with the name, brand, and generic version of the same cereal are collected for several boxes. So this is the one with the brand name cereal, and the one right below it is your generic cereal. So let's look at these things. The mean here is 289 raisins, and the mean here is 249 raisins. So there's a significant fewer raisins found in that generic cereal. And then when you look at the standard deviation, all right, you're talking 19.8 versus 26.34. Well, what that's telling me is that the machines that these guys are using have a lot less variation in how many raisins they pile into that box. They pretty much have a target, and they hit it very, very close a lot of the time. As opposed to the generic brand down here, they have a lot higher variation. So they're a little bit sloppier when it comes into counting out the raisins that goes in each one. Now, they're probably doing it by weight rather than sitting there one by one. But you're still looking at around 250 raisins for the generic box, and just right around 290. Right? So you might spend more for the name brand cereal, but you get more raisins. So that's some kind of expensive raisins. So that's what's going on with number 3. You're just looking for those differences. And that is about it for what we have there. We have a lesson summary. And the big thing here is to look at the variations. The variations for number 2, you're all right from 2 to 16. This thing's all over the place. As opposed for player 1, they're between 1 and 8. So, yeah, a lot of variation on there. They might have means that are a little bit different from each other, but the big thing for my mind is you have a lot more variation in number 2 than in number 1. All right, and that's all we got for that. And thank you.